So we will be discussing about the Chebyshev polynomial first. So what is that? Chebyshev polynomial. Uh, what is my purpose? My purpose is for specified side lobe level, there should be the narrowest main lobe. We have to do the design such that for a specified side lobe level, let's say the specified side lobe level is 15 dB. Okay, so there should be narrowest main lobe, or what distribution can result in smallest side lobe level. All of you please mute yourself. Right. So Chebyshev polynomial, first of all, we have to understand that is given by this thing, say Tmx is equal to, this is mth order Chebyshev polynomial, cos of m cos inverse x. Here x will range from -1 to +1. I will explain, do not worry about this. Okay, and Tmx equal to cos h m cos hyperbolic inverse x when mod x is greater than 1, right? So the polynomial has a certain shape when x lies between -1 and +1, and it has the hyperbolic characteristics. I mean, it varies as cos hyperbolic function when mod x is greater than 1, right? Now, how the polynomial looks like and why we will be using this to find the optimal array, right? So, understand that. See, I'm plotting this, right? Uh, let's say these two lines that corresponds to +1 and -1. This is +1 and this one is -1, and the vertical axis is Tmx and the horizontal axis is x. The plot is somewhat like this. Okay, this plot will be obtained when m will be even. I repeat, this plot will be obtained when m will be even. So when m is equal to even. So as you can observe from this particular plot that the ripples that you are getting are confined within +1 and -1. So you can make the polynomial in such a way so that the side lobe level remains between these ripples, and you can see that there is some rise in this particular curve like this. So this rise in level can be correspond or can correspond to main lobe level. Fine. So I repeat, the ripples that you observe over here lies between +1 and -1. So you can assume that the side lobes are within this particular level, and the main lobe level can be determined from this rise. How can you determine this? See, as I told just now, this Tmx is equal to cos of m cos inverse x when x lies between -1 and +1. So what is that minus 1 and plus 1? This particular level is x equal to plus 1, and in the negative direction x is equal to minus 1. So beyond x equal to plus 1, it rises, right? Let's say I am choosing the value, say over here I am choosing the value as x naught. Say this particular coordinate is x naught 0. Okay. So corresponding to this coordinate, you will get certain value of the Chebyshev polynomial. Let's say this particular point. Okay. So this particular point is, say, x naught b. So what do you observe from here? You observe from here that corresponding to x equal to x naught, you get tmx is equal to b. That means the main lobe level corresponds to this b, and side lobe level will be confined within this plus 1 and minus 1, right? So if you want to increase the side lobe level, increase the main lobe level even more, then what you will do? You will go towards the right hand side of x. Then obviously uh, uh, corresponding to that, you will get certain value of tmx. But there is some limitation. You cannot take any higher values of x, because corresponding to that, you will not get any value of tmx. You can observe from the curve. It has got certain limitations. Suppose if someone says that you want to take the x naught over here, such that you get a very high main lobe level. So you will not get any main lobe level, right? So your main lobe level will be undefined. So it has to be within some range. Okay. So this is the concept. Fine. Now the curve, this is for m equal to even, and for m equal to odd, the curve will be quite similar, but with some minor changes. Let's say this is tmx, and the horizontal axis is x, and as I told just now, that the ripples are limited between plus 1 and minus 1, and accordingly the curve will be like this. Must pass through the center. Okay. So these ripples are like this, and accordingly from here, similar to the previous discussion, corresponding to this x naught value, you will get certain value of tmx. Say this particular point will be x naught comma b. That means tmx will be b, right? So this is the nature of Chebyshev polynomial. Now the question arises, how we can see that it is in the form of polynomial? So let us see how it is in the form of polynomial. I'm rubbing this curve. Right. Now, from these two expressions, let me name this as 1 and 2, right? So let's say T0x. What this mean? T0 means m equal to 0. So if you put m equal to 0, then you get cos of 0, and that is equal to 1. Similarly, if you put m equal to 1, then you get cos of uh, cos inverse x. So that is equal to x. Similarly, if you put T2x, you get cos of uh, 2 cos inverse x, right? So how can you write this? Suppose you assume cos inverse x equal to alpha. Let's say you assume cos inverse x equal to alpha. So therefore cos of 2 alpha will be um, what you can write, cos of 2 alpha, that means t2x equal to cos of 2 cos inverse x. So in place of cos inverse x, let us write alpha. So you are getting cos of 2 alpha. So on expansion, you will get 2 cos square alpha minus 1. Now that will be equal to 2x square minus 1, right? So therefore, in that sense, you get t2x equals 2x square minus 1. So you are getting a polynomial. So you have to cleverly see that whether you are getting a polynomial or not. So similarly, if you keep on increasing the uh, value of m, you will get a polynomial, right? So you are getting a second order polynomial now. Now, if you put m equal to 3, you will get a third order polynomial. And in general, you can verify that if the t of m1 m plus 1 x, that is equal to 2 of tmx t1x minus t of m minus 1x. So whatever, this is a general expression, but I have shown you from this that how you are getting a polynomial. Okay. Now let us see. How you can find the array factor. Now let's say I am assuming that the array factor is nothing but this Chebyshev polynomial. So what I said, let's say the array factor is nothing but this Chebyshev polynomial. Okay. Now if it is so, how can you find the roots of the polynomial? Quite simple. A polynomial, simple. The roots of the polynomial can be found by equating the polynomial to be equal to 0. Now you find the value of the variables. Those variables, values of the variables will be the roots. So roots of the polynomials. So I assumed. So assume that tmx is the array factor, or yes, it is not like that, is the polynomial. Array factor is something else, because array factor will contain z. I will tell you. Okay. So how can you find the roots of the polynomial? Roots of the polynomial can be found by setting tmx equal to 0. Simple. Now, how it is done? Cos of tmx, m cos inverse x, that is equal to 0. Can you tell me why I am taking the equation number 1 and not taking equation number 2 for evaluation of the roots? Okay, without wasting time, I am giving you the answer. So if you remember uh, the diagram that I have drawn, so whatever, this repels, I mean, these are the roots. See, these are the roots. And all these things lies between +1 and -1. So it is -1, this is +1, right? So roots lies within the range of x, which is from -1 to +1, and that is given by equation number 1, and that is why we are using equation number 1 for finding the roots, or cos of m alpha. Just few minutes before I assume cos inverse x is equal to alpha. So putting that over here, you will get this one, right? Now, what are the corresponding values of alpha for roots? So you can find, because ultimately you will find the value of x, right? So corresponding roots are, I am writing alpha k naught. Okay, so k is the integer and naught in the prefix that indicates roots. That means these are the values of alpha that will correspond to the root. So that is equal to 2k minus 1 by m into pi. That is from trigonometry you are getting. Okay, so k is equal to 1 to m. Now once you find this alpha, then you use this expression cos inverse x equal to alpha. So x equal to cos of alpha, right? So you find the values of x, you will get the roots. So what I mean, for each alpha not k, there will be x not k. So what are these x not k? These x not k are the roots actually. So first of all we are finding alpha, then we are finding x. So what we will do, cos of alpha not k, that is equal to x not k. You put the values of alpha not k and you will get the roots. So finding roots is over. But this is not the end, right? Finding root is over, but this is not the end. Why this is not the end? Because if you recall your uh, array factor expression, what it says, we have to again go to the array factor expression. See, the array factor expression says a array factor that is equal to, say, it is I naught plus I1 z plus I2 z square plus I3 z cube plus dot dot dot. Clear? And what is this z? Z is equal to e to the power j psi. Clear? We have to find this array factor. Till now we found only this x. We have not found this z. Clear? Keep in mind over here. So there is a mapping function that maps between x and psi, or you can say there is a function that relates x and psi. I will not discuss how that function is coming, that is not required now. Later on you can uh, discuss with me. So I say in brief that mapping function between x naught k and psi naught k. ultimately we have to find psi naught k, because once we find psi, then we find e to the power j psi, and that e to the power j psi is nothing but z, and once you find z, you will get the array factor. Clear? Now the thing is that, what is that mapping function? Mapping function is, just a second, yes, x naught k is equal to x naught cos of psi naught k divided by 2. So if you rearrange this equation, will you not be able to find psi naught? Yes, you can definitely find that psi naught k is equal to 2 cos inverse x naught k divided by x naught, right? So to brief it, first of all, we found the corresponding roots of the Chebyshev polynomial. So these are the corresponding roots of the Chebyshev polynomial. Now this is not over. We have to find the roots of the array factor, right? So for that we are using this mapping function, right? So since we are using this mapping function, we can easily find psi naught k, right? So once you find psi naught k, you can easily uh, do e to the power j psi naught k to find the roots of the polynomial. Clear to everyone? Now you can question me, yes, x naught k is okay, but what is x naught that appears in the denominator? How can you find that? See, for this, you need to again remember the diagram. What is this x naught? If you recall the diagram once again, say I'm drawing only the one, only for even m. Okay, plus 1 minus 1. Now this is x naught. The horizontal axis is x and the vertical axis is tmx. This is x naught, corresponding to which you are getting b. So from this curve, can you say that tm x naught is equal to b? Yes, obviously you can say that when you put x equal to x naught in the expression, you get uh, in the expression of Chebyshev polynomial, you get b. Now, which Chebyshev polynomial we will be using? Just if you close your eyes and if you remember, if you recall that I have written two forms, one for which I mean one expression that corresponds to x in the range between minus 1 and plus 1, and another one is cos of hyperbolic form for mod of x greater than 1. So obviously you can see from here x naught is outside the range of x minus 1 to plus 1. So we will be using the hyperbolic function to find this, right? So if you do that operation, uh, then what you will get, which implies you can get cos of, now we have to use hyperbolic m cos hyperbolic inverse x, that is equal to b, right? Sorry, over here x naught. Excuse me. Now from here you can find x naught. You find x naught from here. I'm not doing the calculation, which is there in the MATLAB. So from this expression, you can find x naught. Now you put the value of x naught over here to find psi naught k. Okay. So once you find psi naught k, your purpose is solved. How your purpose is solved? See over here, the array factor. I'm talking about array factor now once again. So this same array factor can be written like this: z minus zeta 1, z minus zeta 2, dot dot dot. What is this zeta 1? These are the roots of the array factor that will correspond to nulls. And this zeta 1, what is this zeta 1? This zeta 1 is psi naught 1. What is this zeta 2? This is psi naught 2. Zeta 3, psi naught 3. Okay. So like this, you find the roots and you put over here in the array factor expression, and the final expression that you will be getting, after that you multiply these factors and you will get a polynomial like this, and that polynomial is the Chebyshev array factor corresponding to the Chebyshev polynomial. So what we have done in this, in brief, if I want to explain, then first of all, the Chebyshev polynomial is assumed. Why it is assumed? Because it has got some ripples between +1 and -1. So we will try to locate the side lobes within the ripples, and outside the ripples, we will set the value of x corresponding to the maximum side lobe level. Clear? So this is what we call as Chebyshev polynomial. Is there any question? Have you understood a little from this discussion? I will share the video with you. 2 videos with you. Okay. So if you have any question, then you can ask me. Otherwise, let us see what is the code. To design and plot the radiation pattern of optimal isotropic antenna arrays using Chebyshev polynomial in Scilab, right? Question is, plot Chebyshev polynomials of order 5 and 6. First of all, you have to plot the Chebyshev polynomial of order 5 and 6. That means TMX. So T5x and T6x, how you will plot that. Why this 5 and 6 is given? Because to show you the nature of the curve corresponding to odd and corresponding to even number. This is the code. I advise you to go through the code, right? You know MATLAB. You go through the code, you can understand. So once that is done, you will get these 2 types of plots. This is Chebyshev polynomial of order 5, right? And second one is Chebyshev polynomial of order 6. Now the design problem. Design a 20 element. So number of elements. is specified. In the lecture, I had generalized the concept, say for n element antenna array. So here in practical, we will design for 20 element antenna array, isotropic antenna array, with maximum side lobe level of minus 20 dB. So I want the maximum side lobe level to be minus 20 dB. Also calculate the half power beam width and beam width between first nulls. Right. So I advise you to go through the code and relate whatever I have told in the lecture. You can easily get the results. Very simple code. Okay, see, you can get very simple code. Only you have to do these things and mapping function, and finally you will get the array factors like this. See over here, we want the side lobe levels to be minus 20 dB, and uh, since it is normalized, so maximum main lobe level is 0 dB, fine, and side lobe level is minus 20 dB. So from this, what you can conclude, that side lobe level is minus 20 dB down the main lobe level. Okay, if it is maximum at 0 dB, then it is down by minus 20 dB. If you have any question, you can ask me, or